we have already derived electric field due to a point charge. That means if there is a charge q over here and electric field at this point or at this point or at this point, you can easily do. Suppose point 1 is at a distance r1, then electric field at this point is, if it is a point charge, it will be along the line joining and away. That electric field's expression is 1 by 4 pi epsilon naught, this charge q and the distance r1 square. If it is at a distance r2, it will be along in this direction. Suppose if this is a minus charge, the electric field will be along in this direction, and the same value 1 by 4 pi epsilon naught q by r2 square. Like that it will come. So the other thing here we need to find out is, what is a dipole? A dipole is another topic of discussion which I will do in a separate video. A dipole is something have two equal and opposite charges. One is plus q means the other one is minus q, and separated by some small distance. This is called electric dipole. Its dipole moment, the tendency to rotate in an electric field, is given as P, that is the product of the charges and the distance between them. Magnitude of one of the charges into distance between them, and the direction is from negative charge to positive charge, and the line joining the two charges is called axial line, and that is what we are going to find out. Suppose we have two equal and opposite charges. One is plus q, the other one is minus q. They are separated by a small distance, and the dipole moment is one of the charges, the value of one of the charges and the distance between them, and the direction is from negative charge to positive charge. Okay, here the distance you can consider it as d, then dipole moment will be q into d. But I want to find out electric field at a point on its axial line. So this is the axial line, and along this, here at this point P, I would like to find out electric field. Then I may have a doubt, like electric field obeys in like superposition principle. Then the total electric field at this point is electric field due to this charge at this point plus electric field due to this charge at this point. Then I have to calculate the distance. So which distance I should take? This point P at what distance? Then I may choose to find out from the center of the dipole, the point P is at a distance r. Then what is the distance of this charge plus q? If you take total distance as d and this becomes d by 2, then this becomes r minus d by 2, which I wanted to square in the equation, which is, introducing unnecessary troubles. So what I will do is, I will consider the distance between two charges as 2d, then the dipole moment becomes q into 2d. It's just a mathematical convenience. So what I'm going to do is, the total distance between the dipole 2d, then this distance will be d, this one will be d. If this is r, positive charges at a distance r minus d, negative charges at a distance until this r, this is 1d, the total distance is r plus d. Then electric field at the point P, let us call EP. So electric field at the point EP, which is a vector, because electric field is a vector, because electric field is nothing but force experienced by a unit positive charge. Then EP will be equal to electric field due to positive charge plus electric field due to negative charge, which is the vector sum. Then what is electric field due to positive charge? This positive charge will have electric field here. How do you find out electric field? Electric field at this point is, you have to keep one unit positive charge here. This positive charge will be repelled by this positive charge, then electric field due to the positive charge will direct this way. But if you keep a positive charge here, this negative charge will attract this positive charge, then electric field at this point due to a negative charge will be in a direction opposite. Then if E positive is taken to be along I cap, this E negative will be taken to be along minus I cap. Then the total electric field is, what is the expression for electric field due to a point charge? We have just said that 1 by 4 pi epsilon naught q by r square. Here E positive will be 1 by 4 pi epsilon naught q by r square, where r is the distance between the charge and the point where we need to find out the electric field. The positive charge is at a distance r minus d, so it is r minus d the whole square, and it is along the positive x-axis direction. Then what about electric field due to a negative charge? 1 by 4 pi epsilon naught q by r plus d the whole square, and it is along minus I cap direction. If I take the common, then 1 by 4 pi epsilon naught I can take common, even q I can take common. So 1 by r minus d the whole square minus 1 by r plus d the whole square into I can take I cap outside. Then the next step would be q by 4 pi epsilon naught. You have to take LCM, so which is r minus d whole square into r plus d the whole square. Then here r plus d the whole square minus r minus d the whole square. Maybe you can just pause the video and you can keep on deriving. Then the thing is q by 4 pi epsilon naught. When I expand this r plus d whole square, this is r square plus d square plus 2rd with a negative sign into r square plus d square minus 2rd, and here x square y square can be written as xy whole square. So r minus d whole square into r plus d whole square can be written as r minus d into r plus d the whole square. But r minus d into r plus d can be taken as what? So a square minus b square. In that case, q by 4 pi epsilon naught. See, when I multiply minus inside this minus r square minus d square plus 2rd. So minus d square plus d square minus r square plus r square, 2rd plus 2rd becomes 4rd by r minus d into r plus d is r square minus d square. So r square minus d square whole square. So r square minus d square the whole square. I've done, and the I cap is still out. So I cap is still out. So this thing q by 4 pi epsilon naught into 4rd can be written as 2 times 2rd and 2 times 2d into r by what is r square minus d square whole square. Here I am going to find out electric field due to a dipole at a far point. At a far point means compared to the size of the dipole, the distance where you would like to find out electric field is going to be really very large. Say I will take some typical values. Suppose your r is 10 and d is 0.1. Now that r is greater than d. So r is greater than d. What is r square plus d square? 100 plus 0.01, which is almost equal to 100. So what is r square minus d square? 100 minus 0.01, which is also almost equal to r square. In that line, r square minus d square whole square, I am assuming it to be just r square because I am going to find out electric field at a far point where d is far less than r. In that case, this can be written as r square whole square becomes r power 4. This r and power 4 will be cancelled and leaving r cube. Then 1 by 4 pi epsilon naught q into 2 into 2d by r cube. What is 2d? Q into 2d we just said it is electric dipole moment. Electric dipole moment is the product of charge and the distance between, and this is I cap. Then the electric field is 1 by 4 pi epsilon naught p by, and there is 2p by r cube, and it is in the I cap direction. If you find the same electric field at a point on its axial line on the negative charge side, this value is going to be minus I cap. So just a comparison, electric field due to a dipole is equal to 1 by 4 pi epsilon naught 2p by r cube. So it is inversely proportional to cube of the distance, whereas electric field due to a point charge equal to 1 by 4 pi epsilon naught into q by r square. So it is inversely proportional to r square. Electric field due to a dipole is inversely proportional to r cube. Electric field due to a point charge is inversely proportional to r square.